Hello and welcome to my tutorial. Today we will be looking at two-way ANOVA test. So I have this topic, effects of teaching method and class size on student test performance, a two-way ANOVA study. Today I will be using both the SPSS and PowerPoint slides to enable us understand why we have to use two-way ANOVA test and the basic assumptions of two-way ANOVA test and when to apply two-way ANOVA test. I encourage you to sit relaxed and watch the tutorial to the end so you'll be able to learn how you can do this on your own using your own data. So in this case, you can see that I have the number of students in the class as 30. In two-way ANOVA test, you must have the dependent variable as a continuous variable. If you collected data, for example, in a different context using Likert scale, measurement scale, or using a Likert rating scale, you must have to convert the responses, the data, into a continuous variable, just like I have here, in order for you to have that particular variable as the dependent variable. Now, in this topic, you can see that for us to successfully perform two-way ANOVA test, we need to have at least two independent variables. So in this case, the independent variable number one here is the teaching methods, and then the second one is the class size. And then my dependent variable is the test performance. In this case, that is the score. And then what is the aim of this study? The aim is to learn whether the two factors, I'm referring to these two, whether they will have effect on students' test performance in a class of 30 students. Okay, so if you look at my coding here, you can see that I have teaching method already coded. This is my independent variable number one, this is the independent variable number two. And let me take you to the variable view to understand how I've coded this. So you can see under the test score, there is no value here. I did not impute any value, showing that it is a continuous variable. Under the class size, I have one as small class, and then two to represent those in large class. And then under the teaching methods, I have those in the traditional method coded as one, those into the modern teaching method coded as two. Now let me take you back to the data view. So to perform the two-way ANOVA test, there are some sets of hypotheses that will likely have to guide the data, the analysis. So in this case, you can pause the video to read the hypotheses that I've posed so far. And so I posed for the teaching method the main effect hypothesis, because one thing about two-way ANOVA test is that it gives you the opportunity to check out the main effects, which is specifically for the effect of each independent variable on the dependent variable. So in this case, I want to check the effect of the teaching method specifically on the test scores, okay? And then secondly, the effect of the class size on the test score. And then it also gives you the opportunity to check out the interaction effect of, that is, this teaching method multiplied by class size to tell you the effect, okay? So let's look at the hypotheses that I've posed. And I said there is no significant difference in test scores between students taught using traditional method and those taught using the modern method. And then the alternate hypothesis, we read that there is a significant difference in test scores between students taught using the traditional method and those taught using the modern method. And same applicable here to the point of class size. Under the interaction effect, so I have the hypothesis posed as follows. There is no interaction effect between teaching method and class size on test scores. And of course, the opposite is the alternate hypothesis. These hypotheses allow you to test both the main effects of teaching methods and class size, as well as the interaction effects between them. So let me take time to explain the concept of the interaction term and why we have to need the interaction effect in two-way ANOVA. So I try to summarize that here. And it's like saying you can pause the video and to read out this on your own, but let me give you an idea of why the interaction term. An interaction effect highlights the importance of considering how different factors work together to affect outcomes rather than looking at them in isolation. So let us head over to the analysis to perform this test to see what the result will be in the analysis. So I will head over to Analyze and go to General Linear Model, and I will select Univariate Test. So here in the dialog box, so you can see the dependent variable is the test score. So and I'd like you to keep an eye on the underscore, because SPSS doesn't allow you to have space like test space score. So the only way you can put them together to have them together can be either to merge them together without space or use underscore. So that is why I have all of them named this way. All right, like student ID, test score, class size, and teaching method. So just in case if you are new to using SPSS. Now the test score will be put into the dependent variable box. So I have my class size and my teaching method into the fixed factors. Now the next thing we need to check is to go to the option. I want to see the descriptive statistics. I want to see the estimate of effect size. I want to see the homogeneity test. So this test, this descriptive statistics will give us the preliminary example result of the mean and the standard deviation, and then tell us the number of people in the class, and then tell us the number of those in the teaching method, traditional, and so forth. And then the effect size is going to give us an idea about partial eta squared. So when we get to the outputs of the analysis, we'll be able to understand this clearly. So we click continue. The next we want to do is to check out the EM means, okay, estimated marginal means. So in this case, I want to put all of them into the display means for the class size, the teaching method, and the interaction term into them. And then in SPSS, I'd like you to keep an eye on this. So you can see the interaction means the class size with asterisk, and then by teaching method. Okay, that is like saying class size by teaching method multiplied by teaching method. Okay, all right, so I'll click continue, and then I will go to the plot. I would like to see the plot, the interaction, how it's doing. I like to see that. And then when you check that into any of these can go into anyone. You can have class size into the separate line, we can have the teaching method into the separate line, whatever you want to do, that's not a problem. Then you click add, make sure you click add to have that into the plot. And then here you can use the bar chart, or you can use the line. So but let's first use the line chart, and then maybe later we can also check out whether it will be better understood using the bar chart. So we click continue, then we click OK. So this is the result of the univariate analysis of variance, okay? That is two-way ANOVA test. And so if you go to the first table you're going to see here, it gives us the number of people in the small class, those in the large class. And that will also give us the teaching method. So we have the number, there are all 15 in total for each. So 15 for those in the class, small class, 15 for those in large class, that's a total of 30. Same thing here, that's a total of 30. Next is to move to the descriptive statistics table. Under this table we have that, so this gives us a clearer idea of what we have, better than this. So here you can see that under the smaller class we have traditional methods having 6 students, those in the modern class 9 students, that's a total of 15, just like we have here. And then under the large class for traditional method we have 9 students, and the modern we have 6 students, and that gives us a total of 15. So that's it. So when you check out the total of both the small and large class under traditional and modern, so you have 15, and that gives us a total of 30. And if you go to the SPSS, so you can see that's just what we have here, which is a total of 30 students. Now the next part we want to go to is the Levene's test of equal variances. And I have summarized the Levene's test of equal variances into using the PowerPoint here to explain this concept. And I said the Levene's test is used to check whether the variances of the dependent variables, so in this case test scores in my own example, are approximately, so in your own example, in my own example here is test score. So in your own example, it could be in any context, okay? It could be in a classroom, it could be in agricultural setting, it could be in any field at all. It's not a must that one-way or two-way ANOVA test must be done using student score, no, or in education context, no. So are approximately equal across different groups defined by the combination of levels of the dependent variables. So in my own case, the teaching method and class size. Now I said, if the variances are significantly different across groups, it suggests that the assumption of homogeneity of variances has been violated, which can affect the validity of the ANOVA results. So we want the p-value greater than 0.05. So look at here. If you check the Levene's test of equality of error variances, so you can see that our focus here is to have a p-value that is not statistically significant. If Levene's test, under this part, in line 3, it said if Levene's test indicates that the variances are not equal across groups, you may need to consider alternative approaches such as transforming the dependent variable to address the violation of homogeneity of variance assumption. So in this case, this analysis violates the assumptions of homogeneity test. And normally, if this were to be a real analysis for a real study, this analysis is supposed to end at this point, because we want to be sure that we want to meet a non-statistically significant results here. This line, these, and these are supposed to be non-statistically significant. I hope you get that clearly, but this is for the purpose of demonstration for you to understand, learn how to perform a two-way ANOVA test. So that is why I'm proceeding. If this were to be a real study for thesis or for journal article publication, this analysis is supposed to end here because we have violated the assumption. Now, one way to do that is to go and transform your data using log. that will be performed in a separate video so that we'll be able to transform the dependent variable test score and then be able to use it to conduct this study and then to meet the assumption of the Leven's test of equality of error variance. The next part that I'd like us to look at is the test of between subjects effects. So this is the main place that we want to have an idea of what is going on here. You can see we have the class size, we have the teaching method, and then we have the interaction point or the interaction term. Now you can see that for the class size, we do not have a statistically significant result here. And then you can see that the partial eta squared is relatively small, in fact very, very small, 0.000239. okay. Under the teaching method, we have a statistically significant result here, and then you can see that we have a higher effect size in terms of under the partial eta squared. Then the interaction term, the interaction of class size and teaching methods is statistically significant, and you can also see that the partial eta squared is quite higher. Now, one thing you need to look out for is that when you do not have a statistically significant result under the SIG, the F value will be relatively small, and the partial eta square size will really be little. Now, but when you have a statistically significant result, as the significant value decreases, like becomes small, 0.0000 whatever, the partial eta squared value will be higher, okay. And then you can also see that the F results will also be higher. Now let me take you to my the PowerPoint to explain the test of between factors. If you find that the p-value is less than 0.05, it typically indicates that there is a significant difference between at least one pair of groups formed by the combination of levels of the independent variables. In this case, we're referring to the teaching methods and class size. So when the p-value for the test is less than 0.05, so it means that we will reject the null hypothesis, okay. Secondly, we have the teaching methods. Under the teaching methods SIG value, you have statistically significant result. We note that when the p-value is less than 0.0, so we will reject the null hypothesis. So in this case, it said there is no significant difference in test score between students taught using traditional method and those taught using teaching methods. So this p-value here indicates that that we should reject this null hypothesis and then accept the alternate hypothesis, which says that there is really a significant difference between test scores between those taught using the traditional and those taught using the modern method. Now the interaction term, under the interaction effect, so you can see the SIG value is really 0.000003. That's quite lower. So assuring that the interaction, the combination of class size and teaching methods really contributes significantly to students' test score. All right. And then for those interested in the R-square value and the adjusted R-square value, so this analysis here explains 76.8% variance in the entire analysis conducted. That's the point for the R-square value. So let me take you to the partial eta square test, because if you look at this analysis, you will see the results of the partial eta square. Okay. So let me show you what that means. You can pause the video to copy the reference here and then read up this paper. It is a measure of effect size commonly reported in ANOVA analysis, including two-way ANOVA test. So it indicates the proportion of variance in the dependent variable, so in this case test scores, attributable to each independent variable, so the factors and their interactions. So for the main effects, the eta square tells us the proportion of variance in the dependent variable that is explained by each of the main effects. So in this case, individually, the teaching method and the class size separately. Okay, so if you come to this point, you can see under the partial eta square, you can see the class size here. That's absolutely, so if we click on it, let's see whether we can get something. So you can see the size, the effect size is really low, 0.000239 or 0.00024. If you approximate that, that's quite low, right? Then you can see separately for the teaching method, you can see that the effect size is 0.654. So let us look at how we can interpret that. So for the small size, 0.01 is really small, and then the medium is 0.06, and then a very large effect size is 0.14 and above. So in this case, you can see that we have even far above 0.1. So this is pretty large effect size that we have, that teaching methods really contribute to students' test score. But again, we will go down to estimated marginal means to really know the one that make the actual contribution to this analysis. And same thing applicable to the interaction point. So the effect size for the interaction really gives us the idea. So you can see here we have 0.573, which is quite a huge effect size. So the combination of class size and teaching method really improves students' test score. So that will lead us to the estimated marginal means. So you can see that for the class size, remember we did not find a statistically significant result here. So because of that, if you look at the mean of the class size, you can see it's relatively same, almost similar to each other, and you can see that 82.08 and 82.167. So this is really similar, because we do not have any evidence of effect of class size, right? Under the teaching method, you can see that the mean scores for the modern teaching method is higher, 85.833, and then that of the traditional method is 78.417. So this shows that teaching students using the modern method contributes higher to the test scores than traditional method. So here we can see that for the small class, the interaction of the traditional method has 81.500, that is the mean, and that of the modern class, modern teaching method for small class. Now, in a smaller class, the modern method of teaching contributes higher. You can see 82.67, showing that it's better even in a smaller class when compared to the use of traditional teaching method. And same thing applicable to the large class. So you can see that in the traditional method we have 75.333, but in the modern method we have 89.00. So this is quite higher than the traditional method, so contributing higher than the traditional method. So you can see for the large class we are having 75.33, and you can see that here, 75.33. You can see that's in a large class. And in the small class, for the traditional teaching method, you can see that we're having a little bit 81, close to 82 points. So you can see that that's significantly a reduction effect when you use traditional method in a large class. But in the use of modern teaching method in the class, you can see that in the smaller class, of course, that contributes to 82.66 of the mean, and that is the point here, and then increased to 89.00. You can see 89, almost close to 90. All right. So another way to understand the interaction is, let us head back to the analysis, and under plot, let us look at the bar chart, continue, and then run the analysis again. So you can see here, let us look at this point using the bar chart. So you can see that in the large class, the traditional teaching method lower than that of the modern method. You can see the modern here, and you can see the color on the bar chart. Okay, you can see that of the traditional method. You can see that is lower in the large class. Under the small class size, you can see the modern teaching method also has a significant increase. So this is how you can understand the results, the effect, the increase in the interaction term, and how each of the variables significantly predict your dependent variable. Here I can interpret the results, interpretation of the two-way ANOVA tests results. So I can start by saying that the first part, which is this, I can copy this and paste here to enable me look at it pretty well. Test performance, there was no evidence of an effect. So F into 1, remember 1 degree of freedom here, and 26, 126 bracket open equal to the class size is the F size is 0.06, 0.006 bracket open and close, P equal to 94 partial eta squared equal to 0.00. Then we now put the results of the mean, which is here. So mean small size, I would say then the results of teaching methods shows a significant modern teaching effect on student test scores. Okay, so I put the F bracket open. So I'll pick the result of the F here. Remember, this is 126 this. So that's going to be 1 into 26 bracket close equal to 49.152. So we put the p-value less than 0.000. Using the APA format, I think this is going to be, I don't know, I think it's going to be italicized. Then the partial eta squared equal to, that's 0.654. The means show that, so I'm going to go back to this point, copy this mean for the teaching methods, move these parts, teaching, for the interaction effects. So for the interaction is going to be 1 into 26 bracket close equal to, the F is 34.905, 34.905, so that's 91. Okay, and the p value, p is less than 0.0, and squared eta equal to 0.57. So let me put all of them in two decimal following the APA format. Okay, so I just want to be sure that it's going to be 7. Hope all is well. All right. So for the interaction point, so I will simply paste the interaction here. So this is the interpretation of the results. You may want to also put this table if it's about thesis or dissertation. These tables are pretty important. You need to put them, all these tables, you need to put them into your research. Together with the interaction plots, you need to show evidence of the steps you've taken to do your statistical analysis. So this is how you can interpret the results of two-way ANOVA test, and I've walked you through from the beginning of the analysis using both the PowerPoint presentation, using the SPSS, and the results of the SPSS to demonstrate to you how you can conduct this study. Thank you so much. If you like the video, if you like the tutorial, could you please share? So you can also subscribe to my channel if you have not done so, so you'll be able to get notifications when I post the next video. Thank you so much for watching.